We are on lesson number 3 of trigonometry here, page 514. The first little bit of this should be a review of Math 11. Parts of it anyway will be a review of Math 11 and some of Math 10. So the first little bit here, the trig ratios, the basic ones. Everything we do in Math 12 is right angle trigonometry, so you don't have to worry about sine law and cosine law. So we have a right angle triangle here. This is your angle theta. Looking directly across, you get the opposite side. The one right beside it is the adjacent, and the longest side, or the one directly across from the right angle, is the hypotenuse. And hopefully you remember from grade 10, you've probably seen SOHCAHTOA. I write it slightly differently. I write it like this. Sine S is opposite over hypotenuse. So op over height. Cosine is adjacent over hypotenuse. And tangent is O over A opposite over adjacent. All right, so that's the Math 10. Now the new stuff, I'm not sure if it's new, I can't remember, are the reciprocal trig functions, which basically mean you do 1 over the original trig function. So if you do 1 over sine, you get the cosecant, okay, which is abbreviated CSC. If you do 1 over cosine, you get the secant, abbreviated SEC. And 1 over tan gives you the cotan, COT, all right? If this was class, I would tell you to memorize them. I still think you should, because if you go on, you're going to use them a lot. But you obviously have access to formula sheets and whatnot for everything we're doing in this class from now on. So, hey, at some point, you're probably going to have to memorize them if you do more math. All right, so if we have, now, we should go back here for a sec. If you think about this, sine is opposite over hypotenuse. So 1 over op over height is actually just flip the denominator. That's height times op. So the cosecant ratio is the hypotenuse over the opposite. The secant ratio, which is 1 over cosine, the shortcut is just flip that. So it's going to be the hypotenuse over the adjacent, and the cotan will be the adjacent over the opposite. Now, I don't memorize these. You can if you want. I know these ones here, and then I just flip them at the end if I need to find the cosecant ratio or the secant. So up to you. Again, for this part here, what we're going to start doing in this unit, and you've already seen a bit of it, is everything is on a circle. So it's an XY plane, excuse me. And what we're going to do is we're going to do this is a bad circle, but this is going to be our radius, this will be our angle, this is the X and Y. Now it still makes a triangle here. So when we're doing sine of our angle, sine is, there's my opposite, that's my height, and this is my adjacent. So sine is opposite of our hypotenuse. In this case, that would be y over r. Okay? Cosine is adjacent over hypotenuse, which in this case would be the x over r, because this point here has an xy coordinate. Okay? An x and a y to get to it. Tangent will be opposite over adjacent, so that will be y over x. And then the reciprocal, flip the ratios. R over y, over x over y. They tell you should memorize them. I don't. You can if you want, but yeah, I don't memorize them. The only things on this whole page that I remember is this, and you can figure everything else out from that. Okay? That's all I would expect you to remember is these ratios. Okay? Obviously, you need to know what cosecant, cotan, and secant are, but just know that they're 1 over the primary trig functions, these guys up here. Okay? The rest of it, all this stuff and all this stuff, if you want to memorize it, go for it. I don't, and I'm fine. You can usually deduce what you need from a picture that you can sketch. So I will not ask you to memorize any of this stuff except for the primary trig ratios and the reciprocal ones, right? Just whether they're 1 over sine, 1 over cos, 1 over tan. That is important. Okay. Now, because we're going to start looking at things in a circle, an xy oh my gosh, xy plane, I guess, we'll say that, in circles, there's values to these things, positive and negative, okay? Now I'm going to quickly go through this, and then I'm going to show you a way to just remember it without doing all this. So in the first quadrant, quadrant 1, here's quadrant 1, quadrant 2, quadrant 3, remember from the first lesson, and quadrant 4. In the first quadrant, x is positive, because that's 0, and y is positive, because we went up. So if you look at this, sine is an r, right here, is always positive. It has to be because it's a measure of length, okay? And you're actually using Pythagorean theorem to get it. It would be x squared plus y squared is equal to r squared. So that would make it always positive. So sine is opposite over hypotenuse. A positive number over a positive number, which means sine is positive. Cosine would be, this is our angle theta, be the adjacent over the hypotenuse, which is positive over positive, which means cosine is positive. Tan, which is opposite, positive, over adjacent, positive, which means it's positive. So in the first quadrant, everything is positive. Right? It's the only quadrant that's like that. If you look at the second quadrant, so we rotated all the way to there. Here's our line. Now, if you break this into x, y components, this x is negative. This is 0. We went left. These are negative numbers. But we still went up for y, so that is positive there, positive y. And this is the angle. It's always the reference angle, if you remember that. So sine, opposite, over hypotenuse. And remember, r is always positive. So sine, positive. Cosine is the adjacent over the hypotenuse, negative over positive. So cosine is negative in the second quadrant. And tangent, which is opposite over adjacent, positive over negative. Negative. Okay? And you can do this for each quadrant. Because in quadrant 3, it's negative x, and we went down this time, so it's negative y. This is our angle, theta, sine, opposite, over hypotenuse, so negative over positive, negative. Cosine, adjacent, negative x, over hypotenuse, our cosine is negative as well. And tangent is opposite, so negative y over adjacent, negative x, negative over negative makes it positive. So in the third quadrant, both sine and cosine are negative, but tan is positive. And finally, in the fourth quadrant, x is positive, but y is negative because we went down. There's our angle. So hopefully you can figure this out. Sine would be negative. Cosine would be positive. and tangent would be negative. All right, you can go through and remember that. This just summarizes everything. This is what you need. If you remember this, you can do everything. It's called the cast rule. All I remember is add sugar to coffee. Does excuse me, what it does is the add is quadrant 1, the sugar is quadrant 2, the 2 is quadrant 3, and the coffee is quadrant 4. And it tells you which trig functions are positive in those quadrants. So add quadrant 1, all ratios are positive. And if you look up here, there they are. They're all positive. Sugar, quadrant 2, S. The sign is the only one that's positive. And you can see from here, only the sign ratio was positive. 2, we're in quadrant 3. Tangent is the only one that is positive. Everything else is negative. And coffee, quadrant 4, C for cosine. Only the cosine is positive. Everything else is negative, sine and tangent. Okay? If you remember this, you can answer every question. That's what I remember. I don't remember any of that other stuff. I mean, you can figure it out pretty easily, but for quick calculations, I always use this, add sugar to coffee. Okay, we're going to practice it right now. Determine without using technology whether the given trig are positive or negative. Okay, so I don't want the value, I just want to know if it's positive or negative. 180 degrees. Which quadrant do I end up in? I'm going to wait. Should be in quadrant 4. Hopefully you guessed that. That's 0, 90, 180, 270. I went all the way around there. Okay. Now, I don't care the value of sine 280. I just want to know if it's positive or negative. Remember the cast rule. Add sugar to coffee. We're in the 4th quadrant, which is the only ratio. I'm asking you, what ratio is positive? Cosine. So sine 280 has to be negative. And in fact, if you plug that into your calculator, sine 280, you would get negative 0.984 with a bunch of other numbers. Okay. So all I want to know if things are positive or negative. So I'm going to write out the cast rule here. Add sugar to coffee. Tan 7 pi over 6. Okay. So we're in rads. You can do a quick calculation. Hopefully you remember your basic rads. Pi over 6 is what? Hopefully you said 30 degrees. We have 7 of them. So it's 7 30-degree angles, which is 210. Which quadrant am I in if I'm at 210? So you said 3rd quadrant. Because that would be 180, and that would be 270. What is tan in the 3rd quadrant? Oh, look. T, tan, should be a positive number. Alright, cosine of 10 pi over 3. Pi over 3 is, hopefully you said 60 degrees. So 10 of them is 600 degrees. So, all the way around once is, whoops, sorry, 360. Another 180 is 540. And I gotta go 60 more degrees, so I'm ending up there. Okay, we're in the 3rd quadrant, cosine, but only tan is positive in the 3rd quadrant, so this should be a negative number. And you can check these by punching them in your calculator. Secant of negative 225. Alright, forget about cosecant for now. Just figure out what quadrant. Negative 225, so that means we're going this way. You're going to end up in the 2nd quadrant, because that would be negative 180. That's 0. Secant is 1 over weighting sine. If you do the reciprocal of something, it does not change its positive or negativeness, whether it's positive or negative. Okay, so what is sine in the second quadrant? It's positive. Therefore, cosecant is positive. Okay, cotan. First of all, let's figure out what quadrant we're in. Pi over 6. Again, 30 degrees. And we have negative 13 of them, which will give us negative 390. Which means we've gone 360 and 30 more degrees. So we're actually in quadrant 4. Cotan is 1 over tan. Well, what is tan in the fourth quadrant? The only thing positive is cosine. So this whole thing should be negative. And finally, secant of 1,000, 360, 720, keep going all the way. You're actually in the fourth quadrant. Secant is 1 over cosine. Is cosine positive or negative in the fourth quadrant? It is positive. Therefore, secant of 1,000 will be positive as well. All right. I'm going to give you a quick break. I'd like you to practice questions number 1 and 2. That's what I would do if we were doing it in class right now. And then please go get a calculator for the next section. All right, I'll see you back here in 2 seconds. Okay. All right, hopefully that was okay for you guys. Now, this would be the part in the class where I ask you to take out your calculators. Obviously, I can't watch you do this, so I'm going to explain how to do it. You're probably going to have to go look up how to convert between rads and degrees on your calculator, depending on what type of calculator you have. But if you can convert like numbers like this, 13 pi over 6, into degrees, you never actually have to change your calculator to rad mode if you don't want to. There are advantages of it sometimes, but you don't have to. So, sine of 280. That little thing there tells us we're in degrees. So as long as your calculator has a DEG in the corner, or D for degrees, you're fine. So sine of 280 in your calculator, you should get negative 0.98, right? Tan is 7 pi over 6. So now you have a choice. You can enter 7 pi over 6 in your calculator, but you must be in radian mode. So that means up in the top corner of your screen, and you're going to have to look up how to do this. And it's going to have to say rads or have an R button. Okay, and a lot of calculators will have a it'll look like a DRG button or a DEG button. There's lots of different ways to do this. Again, please look up how to convert your calculator to radians or degrees. So if you do tan of 7 pi over 6 and you're in radian mode, you will get 0.5774. Conversely, you could, if you don't want to switch back and forth between degrees, just convert 7 pi over 6 to degrees. And I'll do it up here. Pi over 6 is 30 degrees, and we have 7 of them. So that's 210. So this should give you the same as if you went tan of 210 degrees on your calculator. Okay. And you can check that. Tan of 210 should give you Sorry, people. 0.5774. All right. Okay. Next one. Rads or degrees. Hopefully you said rads. 10 pi over 3. If you do that in your calculator, you should get negative 0.5. Or if you did cosine of pi over 3 is 60. There's 10 of them, so if you do cos of 600, you should get the same answer. Okay, to you. All right, sine of 90, rads or degrees. Hopefully, you saw there's no degree sign there. Like this one has a degree sign, so there was none there, which means this is in rads. Okay, a lot of rads. So if you do that on your calculator and you're in radian mode, you would get 0.89 or 0. Now, the reciprocal ones, remember cosecant, 1 over sine. We're in degree mode. If you do 1 divided by sine of negative 225, you should get 1.4142. Same for this one. Cotan is 1 over tan of negative 13 pi over 6, which should give you negative 1.7321. And the last one, secant of 1,000. Secant is 1 over cos of 1,000 degrees, which should give you 5.7588. Okay, once you've got that, please try question number 3. And there's only 2 more questions left in this lesson. So try those questions and then I'll meet you back on the next page. Okay, hopefully that went okay. We're not doing this bit. So we're going to scoot down to the bottom here. Determining trig ratios from a point in a terminal arm. So, like I said at the beginning, we're going to deal with XY coordinate plane here and do trig off of that. So we're going to look at rotation angles and reference angles and all that kind of stuff. But one way they can do it is they don't have to give you an angle, they can just give you a point and you can figure out the angle. So we're at the point negative 15. That's my X, that's my Y. Always draw. This one is drawn for you. There's the point 15.8. This is trig, which means we want triangles. And since x always comes first, that's my x, negative 15, and there's my 8. This angle there, the reference angle, is theta. Okay? First thing, calculate OP, basically saying calculate R. I want to know this. Well, that is Pythagorean. Because we have x and y, I can just go x squared plus y squared. You could have done a squared plus b squared equals c squared, but the nomenclature for trig now, if you're on a unit, well, what we'll get to is a unit circle. It'll be x and y. Doesn't matter if you use a squared or b squared, I don't care. So, plus 8 squared is equal to r squared. So what do you get? 225 plus 64 is equal to r squared. R squared is going to be 289. So r, take the square root of it, you're going to get 17. You would get a negative number as well, but it doesn't make sense to have a negative distance, so only take the positive root. So r is equal to 17. Okay. So really our triangle here is completed with 17 now. All right. C. Using this information, determine the exact values of the primary, which are sine, cosine, and tan, and the reciprocal trig functions for angle theta. So basically what they're saying is, I want to put sine theta equals cos theta and tan theta. And then they want the reciprocal of those. So they want to know the cosecant theta, the secant theta, and the cotan theta. Well, it's easier to find the primary ones first. Sine of theta is equal to opposite, which is this side, over the hypotenuse, which is that. So it's just 8 over 17. This is all they're asking you to do, not calculate theta or anything. That'll be later on. Cosine is adjacent over the hypotenuse, negative 15 over 17. Tangent is opposite over adjacent, so 8 over negative 15. Normally you just write it as like that. Or you could have the negative floating in the middle. Doesn't really matter. All right, now once you have those to get the reciprocal ones, just flip all the answers. Cosecant, 1 over sine, so it's 17 over 8. Secant is 1 over cosine, so it's negative 17 over 15. Flip that one. And cotan, finally, is negative 15 over 8. And you're done. Okay, so draw a picture. In this case, they had it drawn. Figure out your radius, your r value, and then just write their ratios. That's it. All right, last question. This is a good question. So cotan A is root 5 over 2, and sine A is negative. Okay. First thing, you have to figure out which quadrant you're in, and we need to draw a picture. Okay. I don't like how they do a lot of the work here. Whoa. Back. Sorry about that, people. There we go. Something. Okay. Draw a quadrant here. X, Y. Okay. Cotan, that is tangent, right? Cotan is tangent. And remember, it doesn't matter if it's reciprocal. Right now, we're just looking for where it's positive and negative. This is positive. Okay? That means tan is positive. And they tell us sine is negative. So remember, add sugar to coffee. Where's tangent positive? Third quadrant. Is sine negative in the third quadrant? Yes, it is, because only tan is positive. So we know from this information, we are in the third quadrant. We don't know where, we don't care. But right now, all I like to know is that I am in the third quadrant. So we're in quadrant 3. Okay. Now, they tell us cotan of A is root 5 over 2. And this is where you have to know your primary ratios. So tan of A is what side over what side? Tan is opposite over the hypotenuse, right? So cotan, you flip those two things just like we did here. Tan, this would be tan is not opposite over hype. Hopefully somebody corrected me, yelled at the screen. Opposite over adjacent. So this would be opposite and this would be adjacent. When I flipped it, that was the adjacent and that was the opposite. So for cotan, we flip it, that means that 5 is my adjacent and 2 is my opposite. So when we're making the triangle, there's the opposite side is 2. I know that is 2. And the adjacent side is root 5. So I know that is root 5. Now, this is the trick here. Hopefully that makes sense to everybody. Look at where we are on the grid. Here's 0. If I go this way, that means x has to be negative. So that's actually negative root 5. And since we went down, this has to be negative root 2. Okay, so just watch that. Just look to see if you need to make them negative or positive. Okay, they want us to calculate r. That's my r. So let's calculate using Pythagorean theorem. X squared plus y squared r squared. X squared, so that's negative root 5 whole squared plus y squared, which is negative 2. Negative root 5 squared, so negative squared is positive, root 5 squared is just 5, plus negative 2 squared, 4. 5 plus 4 is 9, so r is equal to 3. So there's 3. And they want, what do they want us to find? Cosecant and secant. All right. Cosecant A is 1 over sine of A. What's sine of A? Sine is opposite, my opposite side, over the hypotenuse, which is 3. So it's 1 over negative 2 over 3, which is just, flip that, negative 3 halves. Okay? And they want us to find the secant, which is 1 over cosine of A. Cosine is the adjacent, that side, which is negative root 5 over the hypotenuse, which was 3, which gives us negative 3 over root 5. Now, I'm fine if you stop there, but you should not have radicals in your denominator. So if you remember Math 11, you have to rationalize it. And to rationalize it, you multiply top and bottom by the radical, root 5. So what you would get is negative 3 root 5. Root 5 times root 5 is just 5. Now, I'm fine if you stop at that point, but just know the book will rate the answers like this. This will be how the book rates their answers. Okay. Okay. Hopefully that wasn't too bad. Please, if you have a question like this, figure out what quadrant you're in, draw a picture, remember the cast rule, and just go step by step. Information you know, what sides do they tell you, draw it all out. You're probably going to use Pythagorean theorem on almost every question, and then just do the ratios. But remember, if it's a reciprocal ratio, just find the primary ratio and then flip the answer, okay? Please do questions numbers 5, 7, and 8, please. All right, good luck, and let me know if you have any problems. Thanks.